So obviously we need one int box to hold this old flags. Why don't you just call it flags, okay, int flags. And the first call that we do is to get the value of the flags into this box by saying fcntl. So it returns the old value of flags. So flags equals fcntl of fd comma f get f. See, we have already included the fcntl.h. So the value of this f get f is already known to the C compiler. C preprocessor knows this. Comma, no arguments to be supplied, no further arguments, just say 0. Okay. See, mostly this fcntl may not require arguments at all, unlike ioctl may require some additional information. In this case, no further information needs to be supplied. We just, when the thing is supplied, just give a 0. They're saying, 0 is a null address. We don't care, we just say 0. So that is what it is. Now with the flags has got that eventual value. So let us just take that flags, which is n number of bits that you have, xxxxxxxxxxx. Of course, these x are binary digits of bits, ones and zeros. I don't know what they are. Of course, I am interested in two specific of these bits. One is, let's say, this is the osync bit, and this is open. So we are interested in those two bits. We want to force this bit to 0. If it's already 0, it's alright, don't bother. And this bit, we want to force it to 1 if it is 0. If it's already 1, leave it as 1. So then the two operations that we would like to do. And how do we do that is the question. And it's almost universal standard practice. You say, I want to force a bit to 0. What you do is, now remember, this osync itself has got the, osync itself is what we call the rmask, correct? So what is the value of osync? You can write down that. What is the value of osync is all zeros everywhere except a 1 in that particular place, bit position, and zeros elsewhere. So this is what we call the rmask, which is the osync value, right? Now what you can do is, you do one not of this, do a not, that is ones complement operation till day. What you're going to do is flip zeros and ones. So what you're going to get is ones everywhere except the place of that specific bit position, which will become a 0, and ones everywhere else. So I get a new number which got ones everywhere. Now this is actually what is known as the AND mask. This is called the AND mask. This was the R mask. What is the value which is in the header file is the R mask. Now by doing a tilde on that, what you get is an AND mask. Now you see, you AND this with this. AND the two together. What is X and 1? See, X may be a 1, in which case 1 and 1 is 1. Supposing X is 0. What is 0 and 1? 0. So what is X and 1? The X itself doesn't change. So it will be now XXXXX. That means you can see that the other bits are not changed. Correct? XXXXX. What about X and 0? Whether X was 0 or 1? It will always be 0. So that position is always 0. And again the rest is XXXX. So now we have managed by doing this. So that is, let's write the statement for that. Flags end equal to tilde O underscore symbol. End equal to not is a standard practice to drop a bit from an int or a byte. Then I want to set this other X to 1. Maybe it was 1 or 0, it doesn't matter. But that is a very straightforward operation. Now we look at the R mask of the O append. What is that? That looks like 0, 0, 0, 0, 0, 0 everywhere, except a 1 in that bit position, right? Everywhere else zeros. So this is the O append R mask. In fact, it's called an R mask because all you have to do is do an OR operation. Do an OR operation. What is going to happen is, what is X ORed with 0? 1 ORed with 0 is 1, 0 ORed with 0 is 0, therefore X ORed with 0 is X. So it does not change this, any of these bits. So all these will remain whatever they were. If they are 1, they will be 1. If they are 0, they will be 0. And this position, what is X ORed with 1? Is always a permanent one. So now you can see that 0. That means eventually now you got a flags value which got the same bits as earlier for all bits except these two bits, and osync has been forced to 0 and O append has been forced to 1. Is that clear? Yeah, if that is clear, no problem. Then, of course, let's write this statement here. Flags are equal to O underscore append. All you have to do is now to transfer this new value of the int box into the file table row. Correct? You have to transfer that into the file table row so that for the next operations with the FD as the open instantiation, file management system is going to use these new flags for the kind of intentions that we want to do. So that is a FCNTL of FD comma F set F. So in this case, we have to supply an argument saying please set the flags as flags. Is that fine? Is that a problem? These are all some things we have to get used to. sometime in life you have to get used to it. I think it's a good time to start. So I thought I'll add that as part of this discussion. Okay. Anytime you want to drop a bit, use an AND with an AND mask. You want to set a bit R with an R mask. AND mask is the not of R mask. R mask is the not of AND mask. One's complement. Not is one's complement. Flips ones and zeros. So that you have to appreciate that. Once we understand that, is perfectly fine. What I want you to do is now, of course, do a couple of exercises which have been given as part of the class notes.